Hello everyone, in this class we will learn how we can access elements from an array. So to access elements from an array we have two different approach. Any one of those two approach we can use to access elements from array. Clear? So notation or approach to access array elements. Clear? Now the first notation that we have is called array notation, and the second notation that we have is called pointer notation. Look, we already know that array name is a constant pointer. Because of that, we can use this pointer notation also to access array elements. Clear? Now, in case of array notation, we will use subscript operator. This operator is called subscript operator. And in case of pointer notation, we will use plus operator. Clear? Now look, in array how we represent each element. We represent each element with the help of index of array. Clear? So let's say array name is ARR and index of an element is I. Now how we can use these two notation? Look, in case of array notation, how we can access this, the element from ith index? We can use the notation as ARR, then within subscript operator the index, from which index we want to access the element. By using this particular notation we can access the element from ith index. Clear? And this is what we call array notation. Clear? Now coming to the pointer notation. In case of pointer notation we can access the same element. Pointer notation, we can access the same element by using this plus operator, and the instruction will be ARR plus I, then this one. This is how we can access the same array element with the help of pointer notation. This one is called pointer notation, and whenever we access any element with the help of its address, at that time we need to use the indirection operator that we learned in our pointer class. Clear? And this is the indirection operator. Clear? So these two notations are equivalent. We can use any of these two notation to access any element from any particular index. Clear? That means ARR I, this is our array index. This one is equivalent to ARR plus I asterisk. Look, this one represents a address, and we want to access the element that stored in this particular address. Because of that we need to use this indirection operator, because it is a pointer or it represents an address. Clear? Now in this particular notation ARR plus I, here this one is pointer, as this is the array name, but this one is integer. Now how system will perform this particular addition operation? Clear? To know this particular addition operation we need to learn the concept of pointer arithmetic. We need to learn the concept of pointer arithmetic. Clear? Because this is a pointer. So next topic is pointer arithmetic. Arithmetic means which operations are there in the set of arithmetic. We have plus, minus, then multiplication, division, and then modulo operator. Collection of all these 5 operations are called arithmetic operations. Now, all these operations, to perform all these operations, how many operand we need? We need 2 operand. To perform any of these arithmetic operation, we need 2 operand. Let's say the 2 operands are operand 1 and then operand 2. Now, whenever any of these 2 operand is a address or pointer, at that time we called that particular operation is arithmetic operation. Clear? So, whenever any of these 2 operand are pointer or address, at that time that particular operation we called pointer arithmetic. Clear? That means how many combination we have for pointer arithmetic? We can have pointer plus pointer, pointer minus pointer, pointer multiplication with pointer, pointer division with pointer, pointer modulo pointer. Or this is one set of operation where both of these 2 operands are pointer. Now coming to the next part. Next part is any of these 2 operand is pointer and other one is integer. Clear? Now, so we can have pointer plus integer, pointer minus integer, pointer multiplication of with integer, pointer divided by integer, pointer modulo integer. Clear? Here P for pointer. Now all these combinations of operation we have in pointer arithmetic. Clear? But all of these are not valid operation. Which operations are valid and which one is not valid? So in case of both operand or pointer, at that time we can perform only this particular operation. That means only this particular operation is valid when both of these operands are pointer, and remaining all 4 combinations are invalid operations. Now coming to this particular part where only one operand is pointer and other one is integer. In this scenario only these 2 combinations are valid and remaining 3 combinations are invalid. And in this case only pointer subtraction pointer, this combination is valid, and in this case where one operand is pointer and other operand is integer, at that time we can perform 2 operations, and that is addition and subtraction. Now how we can perform these 3 operations, we will learn this thing. Let's say we have declared an array of size 5, integer type. That means how memory will allocate. This is the memory 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, and this is our logical part. That means ARR, it will contain the base address 2001, 2001, 2001. So each of this smaller block size is 4 byte. So 2005, 2009, 2013, 2017. These are the bytes of each smaller, these are the base address of each smaller blocks in the array. That means each base address of each individual elements are these things, these addresses. Now, and this is the base address of the full array. Now the array name points to this particular base address. Now all the elements are initialized with garbage value as we did not specify any value. Now let's say we have 2 pointer, one is integer asterisk p equal to, let's say here we store 2001, and we have another pointer integer asterisk q, here we store 2009. Now we are doing pointer arithmetic as q minus p. So in generally, if P and Q are not pointer, at that time how system will perform this operation? At that time this is just a subtraction operation, and in that scenario the result will be 2009 minus 2001. Now look, here both of these are pointer, that means we have two memory block. One is for P and P contains 2001, and other one is for Q, and in Q we have 2009. Now we are performing this arithmetic operation Q minus P, so the result will be here 8. But this result we get in case of normal subtraction operation, but in case of pointer subtraction operation, that is not the scenario. So in case of pointer operation, pointer arithmetic, this is invalid. Clear? So how system will perform when both of these operands are pointer? At that time how system will perform this subtraction operation? So in this case, when both of these operand are pointer, at that time system will perform in this way. What is the value of Q? The value of Q is 2009. The value of P is 2001. The result of this subtraction will be divided by the size of data. Now both of these are of integer type. Both of these Q and P are of pointer type. That means they are holding address of some other memory location. Now they are holding P holding 2001, Q holding 2009. Now what is the content stored in 2001? What is the content stored in 2009? The data type, the size of those data we need to know to perform this pointer arithmetic. Look, 2001 is this one, 2009 is this one. Now we need to know what type of value stored in these two particular memory block. So one is this particular memory block, other one is this particular memory block. Now what type of value stored in this particular memory blocks? The value stored in these particular memory blocks are of integer type. So we need to know the size required for integer value, and with the help of this, with that particular size, we need to divide the result of this particular subtraction operation. So here it will come size of data. Clear? Now in this case the data type is integer, so the size will be 4. So here we will get 8 by 2, that means here it will be 4 because size of integer is 4. So the result will be 2. Now what does it mean? 2. Now look, when we perform subtraction operation in between two pointer or two address, at that time we get the result as 2. Now what does it mean? Is it a pointer? No, it is not a pointer. When we perform pointer arithmetic, that means when we perform subtraction of two different pointer, at that time we will not get the result as pointer. The result here is number of elements that present within those two address. Look, here the first address is this one and the second address is this one. So within these two address, how many elements are stored? We store 2 elements. We can store 2 integer type of elements here. One is in 0th location and other one is 1 index location. Clear? So as the number of elements that you can store in these two address, the result is 2. So this is the number of elements. Clear? So whenever we perform subtraction operation in between two pointer, at that time what it will give us? It will give us the result as the number of elements that we can store within those two address. Clear? Now let's take one more example. Now the address is 2017 stored in Q. So here let's say the address is 2017. So here it will be 2017. Now what will be the result of this particular operation? The result will be how many elements are stored in between these two addresses. Look, in between 2001 and 2017, total how many elements are there? 1 2 3 4. So the result will be 4. Let's see we are getting 4 or not. The address stored in Q is 2014 minus the next address stored in P is 2001. Now we need to divide this particular result with the size of data. That means here in this case size of data means integer, size of int. So here the result is here the result is 1, this one is 17. 16 divided by size of int, that means 4. So the result is 4. Let's see. 1 2 3 4. So in between 2001 and 2017 there are 4 elements that we can store, and that's why we get the result as 4. Clear? So that is how this particular operation performed by the system. When we perform subtraction operation in between two pointers, at that time the result is not a pointer, even though it is a pointer arithmetic. In such case, the result is the number of elements that are present within those two given address. So we already learned how this pointer arithmetic operation is performed. Now coming to this particular two operation. Look, in this case the result is not a pointer, even though it is a pointer arithmetic. But in this case, when one of the operand is pointer and other one is integer, at that time we get the result as pointer. So here the result is pointer. Clear? Now coming to here, let's say we are performing addition operation p plus 2. Now what is this p? P is a pointer and this 2 is a integer. Now we are performing which operation? This one is it a normal arithmetic? No, it is not a normal arithmetic, it's a pointer arithmetic. So let's do it. Look, if this one is a normal arithmetic, at that time so how system will perform operation? This one is just a normal addition, so it will give us 2003. But that is not the scenario in case of pointer arithmetic. In case of pointer arithmetic, the operation, the how system will perform this operation, it is little bit different. So let's do it how system will perform this operation. Now whenever we add any integer number to any pointer, at that time what system will do? System first multiply the size of data with the integer, size of data. Now in this case, what is the size, what is the data type? Data type is integer. So what system will perform? System will perform p plus 2 into size of int. What does it mean? It means 4. So it will give us p means 2001 plus 8, that means it will give us 2009. Now look, we give the address of first element, that is 2001, and we get the result this one 2009. Here in this particular instruction we give the address of first element, that is 2001, and we get the result of third element, that is 2009. Now what happened here? So what happened here, how we get this 2009, and what is the meaning of this particular operation? Look, when we add 2 with this particular base address 2001, at that time it will give us the result after 2 block. After 2 block, what will be the address? What is the next address that it gives us as result? Now consider here, from this particular block, the next block is this one, the next block is this one. So this one is 1, this one is 2. because of that we get this particular result, this particular address as result of this operation. Clear? Hope you understand the concept. Now what happen if we give 3 here? At that time this particular number will be 3, here it will be 3, here it will be 12, so we will get 2023. Now coming to this particular memory block, here we are adding 3 with this particular address 2001. That means how many block we need to pass? We need to bypass 3 block. So this is our first block, this is our second block, this is our third block. That means we will get the base address of this particular block. Clear? This is how this particular operation performed by the system. Now let's say we change the content of P. Now let's say the content of P is 2005. Now what happened? Now when with 2005, that means now our starting location is, our starting address is this one, and we add 3 with this particular address. So here the value of P is 2005 and we are adding 3 with this particular base address. That means from this particular location block of memory, how many block we need to cross? We need to cross total 3 block. We need to cross total 3 block, or we need to bypass total 3 block. After that, with whatever the base address we get, that base address will give us as result of this particular operation. So let's check what we will get in this scenario. Now when we start from this particular address, at that time this is our first block. So what will be the next block? Next block is this one, next block is this one, next block is this one. This is our third number block that we need to bypass. That means 0, 1 first block, second block, third block. So these 3 block we need to bypass and we will reach to this particular address, that is 2017. So in this case the result will be 2017. Let's see, is it correct or not? So here P is 2005 and the value we are adding is 3, size of data is 4, so we will get, look at here it is 2005 and plus 12. That means we are getting 2017, and that's what we already saw in the picture itself. Clear? So that is how the addition operation performed by the system in pointer arithmetic, and these are the meaning of this pointer arithmetic operation. Clear? Now coming to the subtraction part. In subtraction part also the operation is exactly same. Now in case of addition we are moving towards this direction, that means right direction, but in case of subtraction we will move towards left. From the starting base address, that means whatever the address is given, from that particular address we will move towards left in case of subtraction operation, arithmetic pointer subtraction operation. Clear? And in case of addition we move towards right. Clear? That is the scenario of pointer arithmetic when one operand is integer. Clear? Now let's do it. Now our address is 2005 here. In P our address is 2005, and let's say we are subtracting 1 from this particular base address here. Now from this location, from this base address we are subtracting -1. That means in which direction we will move? We will move towards left direction. And in left direction how many block we need to bypass? We need to bypass only 1 block. So this is our starting block, so we need to bypass only 1 block. That means we need to bypass only this particular block, so we will reach here only. That means the result will be 2001. So let's see, we will get 2001 or not. So the content of P is 2005 minus 1 into size of int, that means we will get 4. So here we will get 2005 minus 4, so the result will be 2001. That's what we get here. We reach in this particular base address of this of this block. Clear? Now what happen if we give q here, and let's say the integer value is q means 2014, that means 2014. Let's do it this one, Q017. Remove all those things. So the content of q is 2017 q minus 2. That means we are starting from this particular location and we are subtracting 2 from this location. That means how many block we need to bypass in left side? In left side we need to bypass 2 block. So from this particular block, first bypass, after first bypass we reach to this particular block, and from here we need to bypass one more block, that means we will reach here. That means the result of this particular operation will be 2009. Let's see, we will get this 2009 or not. So this is our -1, this is our -2, and we reach to this particular block, and the base address of this block is 2009. So the result of this particular operation will be 2009. Let's see it is the result of this operation or not. So the value of q is 2017 minus 2 into size of data, that means integer, so 4 here. So it will give 2017 minus 8, so 2009. That's what we get here also. Clear? So that's how this 3 pointer operation will performed by the system. Clear? In this case, when both operands are pointer, at that time the result is number of element. When one of the operand is integer, at that time we will get pointer as result.